welcome to all. I am recording in the daytime, so slight sound disturbance may be there, but I think it's okay, tolerable, no problem. Slowly I will try to improve the quality by using advanced or sophisticated mic. Now, first, one small recap. I will tell you what I am going to explain now. Just a recap. So therefore, recap, I won't explain much here. Recap. Two concurrent forces, P1 and P2, passing through a point O, making angle theta between them. See, there is absolutely no rule that, first of all, not absolutely, no rule. P1 should be like this, P2 should be like this, nothing like that. But one important, see, you can have even P1 like this. You can have P2 this way. Or even you can have P1 this way and P2 this way also, no problem. There is no need that the angle should be less than 90. So therefore, or you can even call this as P1, this as P2. Just symbols only. But very important, if P1 is like this, P1, P2 should be like that. See, this is correct. But if P1 is like this, but if P2 is like this, then also it is concurrent only. But if you apply law of parallelogram forces, error will come. I will explain to you little later, and then I will give you final summary, or lastly I will give final summary. See, in the full board, I will write summary that you have to refer for any future calculations. So therefore, this all make a note now. Later, I will make final summary. Okay. Now, recap only. For this concurrent force system, R is the magnitude of resultant. I am not writing because this I wrote many times. This is a recap. R is the magnitude of resultant. Alpha 1 is the angle made by the resultant with the force P1, see, like this. Or alpha 2 is the angle made by resultant from P2. See, when you tell angle made by resultant with the force P1 means start from P1, go to R. Or start from P2, go to R. We know that R equal to, already proved last time, this expression, root of P1 square plus P2 square plus 2P1 P2 cos theta. And if you are this angle, alpha 1, I wrote there, alpha 2, I wrote there. Last time I explained by words. Any alpha is tan inverse of other force into sin theta divided by that force plus other force into cos theta. When I give summary afterwards, I will write once again. Okay, now why I am writing all these is because now I will go for some particular cases. See, this is general case. What I wrote is above is general case, applicable everywhere. Okay. Now, particular cases, like see, in that brain teaser problem I asked you, concurrent force system is a particular case of coplanar. General coplanar is separate. But what was the problem there? We derive using for a particular case, apply for general case. But here not that way. Here you are considering only concurrent. Answer still not coming. Okay. Particular cases. So case 1 I will write. Case 1. Suppose theta equal to 0 degrees. See, 0 degrees means what? From the point O1, if P1 is like this, P2 also is same way. See, both are in the same direction going. Anyone is bigger, anyone is smaller, hardly matters. Theta 0 degrees. Now, actually, you do not require law of parallelogram forces, because when both the forces are in the same line of, both forces have same line of action and acting towards in the same direction, resultant is not algebraic sum, just numerical sum. algebraic sum come numerical sum. But anyway, then see here, what happens? Then, see here, theta 0 degrees. Then your resultant equal to, see, substitute here in this formula, root of P1 square plus P2 square plus 2P1 P2 into theta is 90 into cos 90 into cos 90. Now, sorry, not cos 90, 90 degrees for next case, because see, the most important is when theta is 90. I want to go there. So, but now we are discussing 0 degrees. Okay. Such things happen. Cos 0. You know that cos 0 equal to 1. Therefore, equal to root of that, all I won't explain, P1 square plus P2 square plus 2P1 into P2, or equal to root of A square plus B square plus 2AB, mathematics, P1 plus P2 whole square. So that is root of that one. Root of square equal to P1 plus P2. This is the answer for resultant R. And if you go to angle alpha, anyone, see, you can take for alpha. Alpha 1 or alpha 2. Alpha 1 or alpha 2. Anyone you take, see there, you know that P2 sin 0 divided by P1 plus P2 cos 0. Sin 0 is 0. Therefore, sorry, I forgot the tan inverse. See, sometimes happens. Alpha 1 or alpha 2. Or take only one of them. Take only one of them. Alpha 1. Alpha 1 equal to tan inverse of at a time 1. This one equal to tan inverse 0 is 0 degrees. Means P1 this way, P2 this way, resultant also same way. That is, if P1 is like this and P2 is like this, suppose to a point O, then resultant R will be through the same point, will be R equal to, once again, simply P1 plus P2. Okay. Later, I will give summary of all this one. Right now, sufficient. Okay. This is one case. Now take, this is, both are in the same direction, but collinear. Okay. Now, take case 2. Case 2. I see my most important is case 4. Case 4 is the most important. Case 2. When theta equal to 180 degrees, that is P1 like this, when P2 is like this. See here, 180 degrees. Now, logically you can tell both are collinear, have both same line of action, but they are in opposite direction. So resultant will depend whether P1 is more or P2 more. If P1 is more than P2, resultant will be like this, equal to P1 minus P2. If P2 is more than P1, resultant will be this way, equal to P2 minus P1. All I will give explanation later. When I finish all this one, when I give summary, full board I will write. That is to be preserved. See, now if you substitute, resultant R equal to square root of P1 square plus P2 square plus 2P1 P2 into cos 180. Cos 180 is minus 1, or equal to root of P1 square plus P2 square minus 2P1 P2, or equal to root of A square plus B square minus 2AB is either A minus B whole square. See, it is actually what? It is either P1 minus P2 whole square, or it can be root of P2 minus P1 whole square. Why? See, when you write A minus B whole square, A square plus B square minus 2AB. A minus B whole square equal to B minus A whole square. So, your resultant R will be how much? It is root of this is what? It is P1 minus P2 or resultant R equal to P2 minus P1. P2 minus P1. Now you have to apply logic. Resultant R is P1 minus P2. Remember, if P1 is more than P2. Resultant R equal to P2 minus P1 if P2 is more than P1. Or, see here, 10 this way, 8 this way, unit not required. Resultant equal to 2, which side? Right side. Or 6 this side, 9 this side. Resultant equal to 9 minus 6, 3 this side. That's all. Here, resultant will be have direction this way or this way. See that one. For that one, take alpha 1, any one angle. Alpha 1. P2 sin 180 divided by P1 plus P2 cos 180. Cos 180. Now, what will happen is, whatever is this number, see, P2 cos R equal to, see, sin 180 is what? Sin 180 is 0. So it is, sorry, actually, again I am forgetting tan inverse. Alpha 1. Tan inverse of equal to tan inverse of 0. But you should know, since one force is that side, other force is this side, resultant can be either make an angle 0 degree with what? With the P1, or it can make 0 degree with the P2. So see, here, resultant will make 0 degree with the 10 and 180 degree with the 8. Here, resultant will make what? This way it will go. It is 0 degree with 9 and 180 with 6. No problem, because tan inverse 0 is what? 0, or it can be 180 degrees also. 180 also is there. Tan 0 is 0, tan 180 also 0. Therefore, logically you can tell how. Now I will conclude later. Resultant will be in that direction in which higher force of higher magnitude is acting. See, or explain later. 10, 8, resultant 2 this way. 9, 6, resultant 3 this way. Right now sufficient. Later, these are all, see, first of all, for theta equal to 0 degrees, theta 180 degrees, you don't require law of parallelogram forces. Somebody on the road also will tell the answer. If you know little mathematics, or if you understand slightly what is resultant. Okay, now I will go to case 3. Case 3 is purely academic. It is not all that important. Case 3. When P1 equal to P2. See, sometimes, see, I told P1, P2. Long back I was telling P and Q. P, Q are the forces, are resultant. Now I am changing it. I want 1 and 2 suffix. So by chance, by mistake, if I might have told somewhere, see, P plus Q whole square or P square plus Q square, by chance if I tell, you correct it as P1 square plus P2 square. If I use P and by chance if I use PQ, by habit, you change it to P1, P2. That much you can make. So, P1 equal to P2. That is, write a note here. See, in the class, those who are depending on the class only have to write all the details. But I told notes all I am going to write. P1 equal to P2 means both forces are of same magnitude. Then one thing guaranteed, what? Resultant will exactly go in between. Your alpha 1 will be equal to alpha 2 equal to theta by 2, guaranteed. So anyway, calculate. Then resultant R equal to one expression for R. Not much useful for you, but just academic interest. P1 square, sorry, P1 equal to P2. See, you get one thing. See, P1 equal to P2, say equal to P. Both are P. That is, see, one force is P this way, other force is P this way. See, I turned the force. Angle is theta. Now, see, then resultant R equal to P square, P1 square, P2 square, that also P square, plus 2 into P1 into P2 into cos theta. Or if I simplify, root of 2p square plus again 2p square into cos theta. Or I can take what? Or I tell you, see, this is equal to root of, if I take 2p square outside here, 1 plus cos theta. Now remember, mathematics, don't see this theta, mathematics, not this theta. Cos square theta equal to 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. Therefore, 1 plus cos 2 theta, you can write 2 cos square theta. Same way if you apply here, there is 1 plus cos 2 theta equal to. Here 1 plus cos theta is there. Or 1 plus cos theta equal to 2 cos square theta by 2. See here. 1 plus cos 2 theta equal to 2 cos square theta. What cos square theta means 1 plus cos 2 theta. But here you got 1 plus cos theta. If you have 1 plus cos theta here, it is 2 cos square theta by 2. Sorry. Furthermore, in this class, I will not explain. Mathematics are equal to root of 2p square into 2 what? Cos square theta by 2 are equal to root of 2 into 2, 4p square into cos square theta by 2. Or you can tell resultant are equal to root 4p square becomes what? 2p cos theta. 2 into p into cos theta. Sorry, 2 into p into cos theta by 2, not cos theta. 2 into p into cos theta by 2 is the answer. That is the expression for resultant if what? If the two forces are equal. Okay. 2 into p into cos allows 4, root of 4 is 2. Root of p square is p. Cos square theta is cos theta by 2. Okay. This is not important, but other one. Suppose you go for alpha 1. If I go for alpha 1, that is the angle made by resultant with any one of the force. Tan inverse of, see formula, P2 sin theta, simply P sin theta divided by P1. Any correction required? No correction required. Okay. Divided by P1. P1 also is P. P plus once again P into what? Cos theta. Here also equal to, see P will cancel. I won't waste time. Cos inverse of sin theta divided by 1 plus cos theta or equal to tan inverse of sin theta, you can write 2 sin theta by 2 into cos theta by 2. Mathematics. Sin theta equal to 2 sin theta by 2 cos theta by 2. And 1 plus cos theta, just now I told 2 cos square theta by 2 divided by 2 cos square theta by 2 or equal to tan inverse of 2 will cancel. See, cos theta by 2, cos square theta by 2, tan inverse of sin theta by 2 divided by cos theta by 2. You know that it is tan inverse of sin theta by cos theta is tan theta by 2. Tan inverse of tan theta by 2 is theta by 2. Or you can tell angle is, if the angle is theta, this angle is theta by 2, alpha 1, alpha 2 also theta by 2, resultant will bisect the angle between the two forces, or resultant will pass exactly midway. Again, common sense. Okay. This is also not all that important. Now I will go to the most critical one, that is case 4. I will prepare the board for case 4 because it is the most critical part of this law of parallel forces, which has got application. Now consider the most important case case 4, that is theta equal to 90 degrees. See, this way. Or you can tell that is, see, that is means explanation. That is, the two forces are mutually perpendicular to each other. See, that is, if P1 is like this, P2 is like this. Or even P1 can be like this also, but P2 should be like this. Even P1 can go this way, P2 like this. This all I will explain in the second round when I go for summary. Right now we are getting expression. It's a little short class. Next class is the most important, where I will put full summary. In future you have to refer only that one. See, now if P1 is this way, P2 this way, resultant R goes this way, use law of, right here, if you use by law of parallelogram of forces, see, resultant R equal to, substitute, square root of P1 square plus P2 square plus 2P1 P2 into cos 90. All are knowing cos 90 equal to 0. Therefore, resultant R will become square root of P1 square plus P2 square. That's all. This is the expression for resultant. Root of sum of the squares of the two forces. And any one angle, say alpha 1. If you want to go for alpha 1 equal to tan inverse of, see formula, other force P2 into sin theta, theta is 90, divided by P1 plus P2 into cos 90. This I already explained many times. I need not tell every class. Other force into sin theta divided by denominator. That force plus other force into cos theta. Now, you all of you know sin 90 equal to 1, cos 90 equal to 0. Therefore, your alpha 1 equal to tan inverse of P2 by P1. Remember, P2 by P1, not P1 by P2. Alpha 1 is the angle made by the force with the force P1 equal to P2 by P1. This all I will explain in the second half. Or, if you go to alpha 2, see, is tan inverse of other force P1 into sin 90 divided by P2 plus P1 into cos 90. Same, sin 90 equal to 1, cos 90 equal to 0, or your alpha 2 will become tan inverse of sin 90 is 1, P1, this is 0, P1 by P2. There it is P2 by P1, it is P1 by P2. Okay, now, just to understand, if the two forces are mutually perpendicular to each other, you need not use law of parallelogram of forces in general. See now. Or do one thing. You construct the parallelogram once again. See here. Just to understand. Once again see here. Make a note. P1 like this. P2 like this. This angle is 90 degrees. Point O. Represent P1 by, this is the point O, by OA. See, this is P1. Represent P2 by OB. P2. This is OB. Complete the parallelogram. Oh, you are not getting parallelogram, you are getting a rectangle. This is the resultant R. This angle is alpha 1, this angle is alpha 2. Now see here. Directly you can tell. See the right angle triangle here. See, if this is P2, this is also equal to P2 only. That much you should knowing. If this is P1, this is also equal to P1 only. Okay, now, resultant R is directly equal to right angle triangle. See here, right angle triangle, square root of P1 square plus P2 square. P1 square plus P2 square. Oh, right here. Oh, what you got? Same answer. And tan of alpha 1. If you go for tan alpha 1, remember, tan alpha is always opposite side by adjacent side. When you see this triangle, tan alpha equal to P1 by P2. P1 by P2. Or if you go for tan of alpha 2, tan of alpha 2 equal to, see this triangle, tan alpha 2 equal to P1 by P2. Tan alpha 2 equal to P1 by P2. Therefore, you can tell alpha 1 equal to tan inverse of alpha 1, tan alpha 1 equal to, see, tan alpha 1 equal to P2 by P1. What is this one? Okay. P2 by P1. This is a writing mistake. It should happen in the class. See, I am also a human being. But I can make out immediately. See, how I came to know? When you want angle alpha 1 with the force P1, numerator should be other force. So I suddenly came to know something, see, reading mistake. I told, actually, when I told here, I told tan alpha equal to this side by this side only I told. While writing it became other way. See, human being. Okay. So alpha 1 equal to tan inverse of P2 by P1 or alpha 2 equal to tan inverse of P1 by P2. See answer, what you got, same. Now, I will tell why this is very important. See, one more thing, one more note you make here. All the cases over. Before I conclude this class, small class, because summary I want a separate class. I want to talk or tell many concepts there. So I want that summary class, a single class. It may more than 1 hour. This is just a completion of the remaining part of class 2. Okay, now, see, one most important, in the summary I will not tell once again. See, later, right, later, not now, later, when we find resultant force for a multiple number of concurrent force system or any number of coplanar force system, not parallel force system, because parallel forces, only one direction is there. Either concurrent force system, see, you write here, multiple number of, this way, any number, concurrent force system or multiple number of coplanar force system. Write a note here, this way. At that time, we are for getting resultant. I told repeatedly, see, resolution and composition. Resultant is composition. But before composition, you have to go to resolution. There, what first we do is, first you consider reference axis xx and yy. Xx and yy. Make a note now. Xx, yy. See, don't by heart. That side x, this side x. Some people will tell positive x, negative x. No. I will tell them, don't confuse the students. You let them write xx is this. See, you just tell them this is xx. Any side we see later. Then, what we do is, each and every force we resolve along xx and yy. See, or we find the component of each and every force in x direction or along xx axis and yy axis. That is like, see, for example, if inclined force is this way, you find one component this way, one component this way. If inclined force is this way, we find one component this way. This all I will explain later, don't worry. I will tell you why it came this side later. Or if the inclined force is this way, one component will be like this, other component is like this. Then if it is this way, one component like this, one component like this. Then finally, we sum up the components in x and y direction and get two terms called sigma fx and sigma fy. Algebraic sum of components of all the forces in x direction. See, when you go to x direction, all are in one line. See, theta equal to 0 or 180. Then finally we write some force system. See, This is your sigma fx. Answer. Of course, make a note. It can be left side also. It can be left side also. We don't know. And imagine this is your sigma fy. That is same as, see here, P1 and P2. Then when you want resultant R and this angle, at that time I will call angle alpha with x. This I will call angle alpha with y. See, same as this format. I will write at that time resultant R equal to square root of sigma fx square plus sigma fy square. See here, root of P1 square plus P2 square. And I will write at that time alpha x equal to tan inverse of, see, alpha x is tan inverse of what? Alpha 1 is angle made by resultant with the force 1. P1, here P1 is fx. Tan inverse of, if you want alpha x, other force, sigma fy by sigma fx. This again and again I will explain in the summary. And I will write alpha y equal to, if I require, tan inverse of angle with y is sigma fx by sigma fy. Just, I will not prove at that time. See, proof is already here. I cannot, how many times you have to prove same thing? So, now I am concluding this class because what is pending for previous class, law of parallelogram forces, I completed. Now, next class will be very, very critical, and see how I talk. Some will tell or comment, can comment also, sir, your speed is very much reduced. Yes, so that you understand. So next class will be full summary with all the concepts, some do's and do nots, some mistake chances, and how to avoid the mistake. Everything I will explain next class. Okay, this is class number 3. We will meet in class number 4. Thank you.